Hello and welcome to Chapter 12 Code in Action. We are actually going to be looking at what is there in Chapter 12 and run through some code. So, this chapter is the one that brings together the FinOps principles. So, we start by labeling every resource for cost attribution, installing open cost, which is described in the book for real time cost visibility, which is an open source one. Next, we will layer on auto scaling. We'll do both HPA and VPA and budget guardrails. So these are the resource quotas, limit ranges, and all that. So we do that so that there is no runaway spend. Then we will verify that using gatekeeper policies that we did in chapter 11. And then we'll enforce those resource requirements as well as set up Prometheus cost alerts. So this sort of closes with by doing, as always, doing a cost analysis and anomaly detection. So that's basically what we're going to be doing here. So let's open up a terminal and start with the first steps of installing everything. So first thing we will do is install our metric server. You might have this running, but just in case you don't have it, we'll go ahead and install the metric server. Then we will do the VPA. As I mentioned in the book, in the chapter, HPA comes default. VPA is something that you have to install. So in my case, it's available because it didn't install because it was already available. So I was testing this earlier. But you should be able to run this command and get that working. So once that's there, you can actually verify that the Prometheus is running. Yes, because I think we set this up in chapter 4, so we should have that running right now. Now, if it's not running, you can do a Helm Prometheus community add for the Prometheus Helm charts and all that. So since that's there, you don't have to do any of that. Then we can make sure that we are installing the metrics server application. So that is good. The next step is on kind clusters. Typically, metric servers cannot verify that the kubelet TLS certificates are there, right? So if kubectl top node fails, we just need to make sure that it's getting patched. So we'll just go ahead and get that running just in case something is not working. So we will just check. Okay, my metric server is now running. Go to chapter 12. So first step is we're going to apply these cost labels. So FinOps starts with labeling, right? So if you look at the cost labels, cost labeling examples here, you can see how that sort of works. This cost allocation labels, and then making sure that your deployment matches with the cost labels. So that's basically what we are doing here. So as part of doing this, these labels is what open cost ends up using for attributing cost to teams and what gatekeeper enforces to make sure that every deployment is correct. So let's actually apply this. Okay, I think it's all applied. Now it's time for us to install the OpenCost. So OpenCost is a CNCF sandbox project for Kubernetes, as we discussed. So it scrapes the Prometheus for resource usage metrics and then combine that with multiple pricing models and provide more of a web dashboard and a REST API. So we can just go ahead and install that first. Let me see if I have the OpenCost here. Okay, I think I have that. Install OpenCoast. Let me go to that. Okay, great. It's completed the installation, so you can see it's running. Now the next step here is to do a port forwarding so that we can try and make sure that this is something that you can see on our browser. So let's do the port forwarding there, and let's go back and look at the browser. Okay, so we did the port forwarding. We can come and take a look at OpenCoast that we just installed. So it gives you detailed information on what is actually running here. So this is excellent. You can see all the information like your cost allocation, any cloud costs, any external costs, and things like that. Once you have more data, all these things will make sense. Right now, there isn't any data that we have added, but it's installed and ready to go. Now we can come back here. Let's leave that port forwarding running there, and we'll open a new terminal and continue here. Go to chapter 12. So next thing we will do is we'll configure the HPA auto scaling. So we'll first do HPA and then do VPA. So HPA watches that CPU utilization and scales the checkout API deployment, right, between 2 to 10 replicas. And the scalar policy sort of allows you to sort of doubling the pods every 15 seconds. That you can look at the code and figure out. So we will go ahead and run this one, API HPA. Let's see where that is. Check out API HPA. So you can just come in and look at this code and see how this works. And now let's run that and see if that's good. So we'll run this one. You can see that it's done. So essentially what it does is that it's sort of targeting about 70% CPU with minimum of 2 and max of 10. So with that there, you can see that 70% there. Now we can actually do the VPA. So VPA is not installed in the Kubernetes, which is why we separately installed it. Now VPA has 3 components like we talked about, and there's the recommender, the updater, and the permission controller. So we installed all 3. So that's where we start from. So we will go ahead and run this. Okay, that is good. Now we will go ahead and run our kubectl commands for this. Okay, let's see if it did it. Yeah, it looks like it's all running. That is good. Now we can start doing the, so essentially what VPA did here was it did it with the auto update mode, basically making sure that the recommendations will appear with about 8+ hours of workload data. So if you leave it running for some time, you will see some data around that. Okay, next thing we are going to be doing here is going to be applying the budget guardrails. So this budget guardrails, let's see where so this is where the budget guardrails code is. So what this does is it creates the tiered resource quotas and limit ranges for each of the environments. In your case, dev, staging, and production namespaces. So resource quotas cap the total CPU memory pod count for namespace, and essentially making sure that no single team is consuming the entire cluster, and limit ranges sets the default resource request for every container. That's needed because you don't want pods to run unlimited even if the developer forgets to specify the resources. So that's what we will do here. Okay, we can see that that is working. Okay. Now, after that, the next step is, remember in chapter 11, we deployed the OPA gatekeeper with constraints that require resource requests and limits on every pod. So those constraints are still active. So whatever we are running active. So if it's not, you should go back and make sure that those constraints are running. And then we will actually we'll first start by looking at what is running here. Constraints. So we can see these are the constraints that are running. Remember all these from last time we ran it. Okay. So all 6 of the constraints should be there. 1, 2, 3, 4, 5, 6. Good. Now we will temporarily enable the deny enforcement to demonstrate a live rejection. So that you see how that works, right? So we will enable this. Okay, that's patched. Now we will run test pod here. Okay, so essentially, yeah, this one is already running from last time. So now we should be able to see this one, the enforcement. Okay, so that is run. So you can see that this admission webhook denied that request, right? I mean, so the container must have then resource limits and all that. Okay, so next step here would be for us to look at deploying the cost alerts. So cost alerts YAML, which is here, cost alerts YAML. Do you have here? This defines the Prometheus rules that fire alerts when cost thresholds are breached. And we have cost anomaly detected here, as well as high scaling rate below that. Both of those things available, and then you will be able to see these alerts integrate with the existing alert manager that we set up in chapter 4. Now we can do the deployment of the cost alerts. So if you look at our cost alerts YAML, you will find the appropriate information there. This sort of defines the Prometheus rules that fires alerts when cost thresholds are breached. So this will include both the cost anomaly detected, should be, yeah, so you see the cost anomaly detected, as well as high scaling rate and budget exceeded. And these all integrate with the alert manager that we put in place in, I think, chapter 4. Okay, let's try and run this and see how this works. So did it work? Okay, so you can see that these anomalies, cost anomalies, as well as everything sort of set up there. Okay, that's good. Now we can sort of generate load and watch the HPA scale. So what we will do is we will actually go and run this in one terminal here. Then we'll open another terminal, and then we'll watch. So what we did in the previous terminal was we started the load generator, right? Let me just show you one more time. Where did that happen? So yeah, we started the load generator here. You can see that. And in this one, we will actually go and run the HPA, how the HPA reacts to that. So when you have something really there to scale, it'll show that. So currently the HPA is showing unknown because there is no checkout API deployment actually running the team checkout namespace. So HPA is created, there is nothing to scale. So what happens is that cost labeling examples that we looked at creates a namespace, but doesn't deploy a workload. So and that basically proves what's happening here. And one additional exercise that you can consider is to create a simple checkout API deployment manifest so that HPA has something to scale. So that would be that additional thing that you would end up doing here if you would like to see how that scales. So next thing we do is we will run the cost analyzer scripts. So cost analyzer.py here. You can see that here, cost analyzer.py. What that does is that breaks down the resource consumption by namespace, workload, and resource type into a JSON report. So your cost anomaly detector.py, that is the other one here, cost anomaly detector.py. That generates a synthetic cost data, right? I mean, just simulates some cost data and applies statistical thresholds to identify various spend patterns that you might have. So ultimately, the purpose of the script is to sort of demonstrate how platform teams can build automated cost reporting into their workflows. Okay, let's run the cost analyzer.py right now. Okay, it did the analysis. So the reason why you see warning could not retrieve metrics is because it deleted the metrics server API earlier. and the script sort of falls back to zero values, gracefully, right? I mean, that's the purpose here. So overall analysis is generally correct as to what you're trying to achieve here. Now we can run the cost anomaly detector. It ran and told you that, yeah, there is no anomalies detected, and now you can run the test cost optimizer. You can see that the 14 tests ran and it went through. Thank you.